Um, I think I'm live. I think. Okay, so let me just go back. All right, welcome everyone. Today we're going to be solving every single one of the AP Calculus FRQ's free response questions. So if you took the test, then I hope you did amazing. You probably did. Hope all of you passed. And if you didn't, I hope you still enjoy. And how the test works is we have 6 free response questions in each test. However, 3 of them are shared, which means there are 9 total. So let's just jump right into it. Actually, let me pull up the chat. Uh, okay, I'll just alt tab to look at the chat. Okay, so let's start with the BC questions because we have some AB questions mixed in there too. So let's go to the first question here. So these are both calculator questions. So you get a TI-84 graphing calculator for these. Let's read the first question. It says, the temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c. Okay, so we have basically a cup of coffee. It's hot and it's getting colder. It's like cooling to room temperature, basically. Where c of t is measured in degrees Celsius. Okay, so we have some units. For 0 to is less than t is less than or equal to 12. So t is like a 12-minute interval. Selected values of t are given in the table shown. So it gives you like these values. This is like a discrete table. So we're probably going to have to do some Riemann sums because that is simply how the AP exam works. They like to give you Riemann sums. Okay, so what does part A want us to do? It wants us to approximate c prime of 5, or the derivative of c, at t equals 5 using the rate of change of c over the interval 3 is less than or equal to t is less than or equal to 7. Show the work that leads to your answer and include units of measure. Okay, so this is just basically an average rate of change, which is going to be kind of approximately equal. So like basically if you have any function, if you take these 2 points and draw a line and find the slope, that slope is basically kind of close to the derivative. That's kind of the idea. Okay, so c, you can write that c prime of 5, and make sure to use this approximate symbol. I'm not sure if you're actually going to lose points if you don't do it, but it's just safest if you do. Is equal to c of 7 minus c of 3 over 7 minus 3. So this is basically like a slope. So the slope is not the exact derivative, but it's going to be pretty close. And reading from the table, this is equal to c of 7, which is 69, minus c of 3, which is equal to 85, divided by basically 4. And you can use a calculator for this because you have one, but this is equal to negative 4 because negative 16 and then divide by 4. So this is equal to negative 4, and then what's the units? This is going to be degrees Celsius per minute. So you can write out words degrees Celsius. They'll probably also accept it if you put like the C with the degree per minute. But you can also write it like this, per minute. Okay, so that was pretty light. They usually don't start off too complicated. And okay, so let's keep on going. Part B says use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the value of the integral from 0 to 12 of c prime of t dt, and then interpret the meaning of 1 over 12 times the same thing in the context of the problem. So make sure you know what they're actually asking you to find. You want to find this value here, and that doesn't want you to find this. It doesn't want you to find this, it just wants you to interpret the meaning. Okay, so let's start with the first part here. The Riemann sum, you can always just start with this integral from 0 to 12 of c of t dt. This is approximately equal to, and then what's 3 subintervals? This intervals are just 0 to 3, 3 to 7, and 7 to 12. Riemann sums, this is a left Riemann sum, so we want the values on the left. So that would be first interval, which is a width of 3. You can write 3 minus 0 or just 3 times the left value, which is 100. So this is like the first rectangle. plus the second interval, which has a width of 4 times the height, which is 85. And then plus the third interval, which I had more room. But okay, third interval has a width of 5 and a height of 69. Okay, so now you have a calculator. Obviously, you can just work this out. But this is 300 over here. This right here is 340, if I'm not mistaken, so 640. And this here is 345. That does not... Yeah, 300. Okay, 345. So that's 900 equals 985. And you'll probably want to put some sort of units. This would be... What even would be the units? Degrees Celsius times minutes. Yeah, okay. But the value of... Yeah, you can put units or not units. It didn't ask for it, but it's safer to put units, and that would be basically Celsius degrees Celsius times minutes. And this is kind of a weird unit, but next tells you to interpret the meaning of 1 over 12. And 1 over 12, this is the average value. So you're taking the integral and then dividing it by the width of the interval, which I think we might be back. Okay, I think we're back. Okay. Let me just make sure. Okay, we're back. Let's go. All right, let's continue. All right. All right, George said, do you think it's okay if I write the average value of the function of the temperature of coffee at a given time t? So the average value, usually what that refers to is over the entire interval. So I think, I don't know, if I was a table reader, I'd probably give you the point just for saying the average value. But this integral here is referring to represents it's just the average value. Oh my goodness. Wait, what is going on? Can I type? Okay, I think we're back again. This is very weird. Okay, represents the average value of the temperature in Celsius from t equals 0 to t equals 12. Okay, so that is part B. I'm taking up a lot of space, so I'm actually going to go ahead and clear these. It's probably a better way to clear it, but okay. Just check the chat. Hold on, let me look at my... Oh no, my stream status is poor. Uh-oh. It's okay. I think if you add like I think if you add a delay, it might be a little better. But okay, let's go to part C. it says for T from 12 to 20, the rate of change of the temperature in the coffee is modeled by C prime of T equals negative 24.55, this whatever, in degrees Celsius per minute because it's a rate. So find the temperature of the coffee at time T equals 20. So when it gives you a rate and it wants you to find an exact value, this is going to be a start plus accumulation type of thing. So you can say you basically want to find C of 20. So you want to find C of 20. Oh, I keep having. I think I just have to reconnect and disconnect from my monitor whenever it freezes, which is really annoying. But it's going to be fine. Yeah. Okay, so it's equal to the integral from 12 to 20. Well, there's actually something before that. So it's C of 12 right here, and then plus basically the accumulation from 12 to 20 of C prime of T. Okay, dt, and this is where actually the calculator is very nice. So this right here is 55, and then this here you can just plug in this thing over here in your calculator. So you can go to y equals in your calculator and then put in this weird function negative 24.55 times e to the 0.01 t, and it says t, but you can use x in your calculator. It's this exact same thing. And I wonder if this is actually like realistic for like heat transfer or whatever. If you like physics, you can answer that question. But just it's 55 plus the integral, which is you get from Math 9, from 12 to 20 of, and you could just go to alpha, click trace, and then enter would be y1, and then dx like this. And then that gives you 40.3291, and in AP Calc we like 3 decimal places, rounded or truncated, but just round because rounding is superior. And this would be just Celsius. Okay, so I think that's good. Wait, what? All right, so now let's go to part D. For the model defined in part C, it can be shown that C double prime of T equals this thing, which is you're just taking the derivative, and then for this same interval, determine whether the time of temperature of the coffee is changed at an increasing or decreasing rate. Give a reason. Okay, so changing at a decreasing rate, changing implies a derivative, and then decreasing rate, that's another derivative. So we're actually just using the second derivative, and it's kind of related to concavity, whether it's whether it's like this or like this. Okay, so let's just look at this function here. It looks like a lot, but we can actually break it down pretty, like we can break it down by breaking it into parts. So t is always positive here. And when you look at this part, this is a constant. That's always positive. We really just want to see if the second derivative is positive or negative. Okay, so the constant part, that's always going to be positive, and then e to a positive number, well, e to the x is just always positive. It's always positive, no matter what you put into it. And then 100 minus t, 100 minus 12, anything from 12 to 20, that's also going to be a positive number. And then in the denominator, you're squaring it, so it doesn't even matter if these are positive. This is always going to be positive also. So you can say that because C double prime of t is greater than 0 for all t in this interval. Oh my. For all t in this interval, the temperature of coffee, I'm just going to abbreviate as TOC, is... No! I wonder if I just stay on my monitor, it's going to be better, but the camera's going to point in a weird direction if I do that. Yeah, mouse handwriting. I don't have a stylus on it's not a touch screen. Okay, from t equals 0 to t equals 12, that is another, wait, what? Oh, I didn't erase that. Okay. This is from part B. The temperature of the coffee is changing at an incre oh my. This is gonna look really weird on the video, but I'm basically switching. I have to plug in and unplug my thing to my monitor to whenever it lags out. Really annoying. Okay. At an increasing. No, it just. What the heck? Yeah, you did. Super ch Oh, super chat? Like donations? No, I don't have donations on. I don't, no, no, don't give me your money. Why am I recording now? What? No, why my exclamation point in OBS? Okay, what if I just go back and keep going? Is changing at an increasing. Okay, we're done with that problem. We're done with that problem. We're moving on. Finally. Okay, so for number 2, we have a particle moving along a curve. So this particle, it always goes to give you a particle because a particle has no size. Okay, so it has position x of t, y of t at time t seconds. My stream's back, right? Okay, we are back. Alright, x of t and y of t are measured in centimeters. It is known that x of t equals this and y of... Oh, x prime of t. See, they're being tricky. They're being tricky. They just give you the straight-up derivatives. First derivatives. Okay. At time t equals 2 seconds... so this is going to be like a... They're going to ask you for an actual position. This is an initial condition. So something initial condition. Okay, so find the speed. The speed. Okay, what's the speed? Speed is the absolute value of velocity. And so v equals x prime of t, comma y prime of t. Okay, I'm just going to switch back and forth. It's going to look really, really weird. Y prime of t. So that means the speed equals the square root of x prime of t squared plus y prime of t squared. And then I'm pretty sure you can just, I don't know, you can replace these with 2's. And then that's going to give you a number. And I don't really want to put this in my calculator, but I guess I will. So it's the square root Oh, you should probably put this in your y equals, because if you're looking ahead here, it asks for the total distance traveled in part B, and the total distance traveled is the integral of this speed. So you're going to want to like save this in your graphing calculator so that you can reference it. So you're gonna want to put the square root of 8x minus x squared, and that's all squared, and then plus negative x. Well, it's t, but in your calculator it's x. Square root of t, or x to the 1.2 plus 20, and that's also squared. Okay, so once you have that, you can just do in your calculator alpha and then trace y1 and then put parentheses. Y1 is basically a function, y1 of 2, and that's 12.305. And then centimeters. Okay, so centimeters per second. Yeah, there we go. So this is a Calc BC only question. I don't think this is not on the AB. And okay, so part B now. Total distance. Okay. Now I'm back on my main computer. Anyways, total distance. Dist. I'm gonna start really abbreviating. Don't do this on the exam. I hope you didn't. But dist equals the integral of speed from 0 to 2 dt. This equals, you can just basically just put all of this over here. So the integral from 0 to 2 of the square of, yeah, x prime of t squared plus y prime of t squared dt. And the nice thing about this is that you can just take y1 from your calculator and put it into your, like your whatever entry bar, or what it's called. So 0 to 2, and then just put y1 in here, and that's already a function, so you can just put dx after that, and it should look something like this. So you'll get 15 point not 15.902, and that's the distance, so centimeters. And I'm also, yeah. All right, so let's go to part C now. The y coordinate. Okay, yeah, so that's finally talking about the y coordinate. We want y of 0. So this is going to be something kind of weird. Start plus accumulation also works backwards. So you can actually just do y of 2 plus the integral from 2 to 0 of basically y prime of t dt. And if this like makes you uncomfortable, you can also say that y prime of 2 equals y of 0 plus integral from 0 to 2 of y prime of t dt, and then this would be the exact same thing because this over here is the negative of this over here, so you're just kind of switching it around. But either way, I'd probably use this one just because this is like fancy, and it kind of breaks conventions, but there's nothing like against having integrals with a higher lower bound than the upper bound. But no matter how you do this, y of 2 we already know is 6. So this is 6. And then this integral in your calculator, you'll actually have to type out this part because unless you saved them individually in your calculator. But the integral from 2 to 0, and your calculator has absolutely no problem with that, of negative x plus the square root of x to the, I'm saying x, but it's t, 20 dx equals this part is negative 7.17 or 4, whatever. But 6 plus that is negative 1. I really wonder how this is going to look like in the VOD. But I'm just switching between back and forth. Okay, we're back. And also, can you hear me? Okay, is the audio fine? So this is going to be negative 1.174, and this is centimeters for the y coordinates, and then you're going to get the same answer from this method too, just because that's how math works. For 2, oh no. For 2 is less than t is less than 8, the particle remains in the first quadrant. Okay, so first quadrant, that's like right here. Final times t when the particle is moving toward the x-axis. So the first time I read this, I actually got confused, but this is the x-axis. This is horizontal line. So if you're moving toward it, that means your velocity in the y direction is negative. So that basically means that y prime of t is less than 0 because you have a positive y value and you're trying to move down towards the x-axis. So this means that negative t plus the square root of t to the 1.2 plus 20 is less than 0. So how you can solve this is you basically say that you can set it equal to 0 in your calculator, and then find where does t using the intersect. It's like an intersect mode. So what you do is you put negative t plus the square root of x to the 1.2 plus 20, and then you can just put like y2 as 0 and then go to your window. And then for your window, you'd want to put x is from 2 to 8, and then since you want it to intersect 0, all you really need is y from negative 1 to 1 or something like that. You can also leave yourself some room for like, you can put like 1 to 9 or 0 to 10. Okay, so when you do that, that's going to be second and trace intersect. And then it's going to draw you something nice. Alright, audio's fine. That is great. Okay, we only see one. We only see one intersection, and what that means is it's negative over here. So alright, t. Yeah, you can basically like write set equal to 0 or something like that, and then just write t equals 5.2. Oh yeah, and I'm curious, what does it look like when I like just switch? Because it just shows like the swirly circle, right? And then does it just go automatically? That'd be good. But okay, so t equals 5.22 seconds, and basically y of t is less than 0 for, and if you look at the calculator, it's like as x increases, but x is actually t, that's when it starts becoming less than 0. So this is for t is greater than 5.222. So finally you can write from, yeah, 5.222 is less than t is less than 8. Particle moving toward x-axis because y prime of t is less than 0. Alright, let's move on. So I'm going a bit slower because I'm trying to explain it, but usually you get 15 minutes for each of these questions, so we're actually quite on pace here. All right, so we got a slope field, very, very juicy. Depth of seawater at location can be modeled by the function h that satisfies the differential equation. So they're giving you a differential equation, and this is the slope field that you get from the differential equation. So, quick review on slope fields. At any point, the line represents the slope. So you can kind of like trace out some functions, and that's exactly what it tells you to do. It gives you this thing here, like it has it has an h in it, also has a t in it, and it also has a cosine. Yeah, I don't know what the map would look like. If you like topography, you can like draw a map and see what it looks like. Where h of t is measured in feet, t is measured in hours after noon. Oh, so it's like a tide. So it's like a tide. Okay. So it's known basically like cosines, like a periodic. Yeah. So afternoon, and noon is t equals 0. It is known that h of 0 equals 4. So this gives you another initial value. It's like an initial value problem. So a portion of the slope field is provided to discuss the solution curve. So the solution curve, if you've ever done this in like Delta Math or something, it's really cursed. But you just follow the lines. Can you follow the lines? Just follow the lines. Something like this. Just follow the lines. And I don't know. I don't know if it makes you do the arrow or not. I just do this. Like this is going to get you the points. Just follow the lines. That's all you really need to do. Okay, so part B. Let's go back to the chat. Okay. For 0 less than t less than 5, consider that h of t is greater than 1. Okay, why would it tell us that? Well, it tells us that because, well, it's a surprise tool that will help us later, basically. Find the value of t from 0 to less than t less than 5, at which h has a critical point. Determine whether the critical point corresponds to a relative minimum, a relative maximum, or neither a relative minimum nor a relative maximum at the depth of seawater at the location. Justify your answer. Okay, so to find critical points, we have to find the derivative, but we already have the derivative. So we want to basically set it equal to 0. And this is also equal to 1/2 of h minus 1 of cosine of t over 2. This, if this is 0, then one of these needs to be 0. Okay, so can this, okay, this is a constant. Constants are never 0 unless they're 0, but this is not. Don't ask why it's not, though. 1/2 is just not equal to 0. Okay, h minus 1, it told us that h is always greater than 1. So if it's greater than 1, something greater than 1 minus 1 is never going to be equal to 0. Okay, so these can't be 0. Cosine of t over 2. Basically, this means that cosine of t over 2, you can write like this part here, not equal to 0. Cosine of t over 2 equals 0. And when does this happen? Well, first of all, you can just look at this graph. Oh, when does it look like it have a relative maximum? Oh, 3. And it looks like 3. Oh, what other number is equal to 3? Pi. Is pi from 0 to t to 5? Yes, it is. So it looks like it's like somewhere over here at pi. And indeed, cosine, if you look at the unit circle, cosine of pi over 2, which is right here, is indeed equal to 0. And that is... All right, Jared, you cooked. I'm very happy to hear that. Okay. Cosine of, so as I think I was saying, cosine of t over 2 is 0 at t equals pi, and this is indeed in the interval. Okay, so now, is this a relative minimum or maximum? There are a couple ways to figure it out. You can do a second derivative test, but that involves differentiating this non-homogeneous equation, which means that there's basically h and t in it. It's not just one variable. You do not want to do that. Instead, you can make an argument that, okay, this is always, it's not only not equal to 0, it's also greater than 0. So the sign of the derivative is only going to be affected by this part over here. And what that means is you can say that you can make a number line. Number line is not justification, though. As of, I think Calc 3 lore says that, I mean not Calc 3, AP Calc lore says that number lines are no longer justification. They used to be, but they aren't anymore. You can write that for t is greater than pi, basically that's going to be over here. Cosine is going to be negative. So dh over dt is less than 0. Yeah, and for t is greater than pi, dh over dt is greater than 0. And that makes sense here because it's like, oh, it's going up and then it's going down. Okay, and then so therefore, because of that, that's just the justification. Therefore, the h is at a relative maximum. My maths handwriting is deteriorating, but okay, relative maximum. Actually, I should this says maximum. Current stream bit the current stream's bit rate is lower than the recommended bit rate. Well, okay, I don't know what you want me to do about that. Oh wait, I'm on good now. Stream status is good. Wait, let's go. Um, okay, maximum at t equals pi. All right, I think we're good. And now we actually have to solve the differential equation. So we're gonna need a lot of space. I'm gonna erase all of this. Okay, so now we actually have to solve the differential equation. You're gonna have to use you're gonna have to do separation of variables, and then integrate both sides, and then you're gonna have a plus c on both sides, but you can like condense it into 1 plus c, and then plug in the initial condition, solve for c, and then you can get the solution. Okay, so what do we know? We know that this is part c now, dh over dt equals 1/2 times h minus 1 cosine of t over 2. Okay, cosine of t over 2. Now, the first point that they give you is separation of variables. That means you want to get all the h's on one side and all the t's on the other side. So that means dh over h minus 1, or you can write 1 over h minus 1 times dh, equals 1/2 cosine of t over 2 dt. Now you can put this 1/2 wherever you want. You can move it over here if you'd like, but it actually makes it's a lot better if you do it like this, just because of how the chain rule works and like u sub. Okay, so now you want to actually integrate both sides because you have the variables all on the same side. Okay, so over here, h minus 1, this is 1 over a linear function. That's going to be the antiderivative of that is a natural log function. So the natural log of the absolute value of h minus 1, but we're actually given that h is always greater than 1, therefore this part here is always positive. We don't actually need the absolute value, we can just put straight parentheses. This equals here. You can do a u sub, but it's so simple here inside the function that you can basically just think, okay, what's the antiderivative of cosine? It's sine. If you just have sine of t over 2, taking the derivative of that is going to be cosine of t over 2 times the chain rule, which is 1/2. That's just going to put the 1/2 here. You can also think of it as dividing by the chain. So dividing by 1/2, 1/2 over 1/2 is 1. So you have a 1 over here. And this is going to be plus a c, plus a constant c. So you have this initial condition. A lot of my teachers, and I also agree with them, they recommend to find c as early as you can because that gives you a point. So even if you mess up the stuff after that, you still get the point. So plunging in, so h of 0 equals Alright, if I could go 5 minutes without having to switch between monitors because of the lag, that would be fantastic. But okay, h of 0 equals 4. So ln, the natural log of 3 is equal to sine of 0 over 2. This is actually very, very nice, because sine of 0 is 0. Plus c, this right here is 0. C equals the natural log of 3. Okay, you can, I don't know if you'd want to box it, but this would give you a point, plus 1 point. And you also get plus 1 point for integrating both sides, and then also for separation of variables. These are always worth 5 points. I don't know, I think I missed a point maybe somewhere there. You also get a point for like, oh, you get a point for each of these by raising e to the power of both sides. Okay, so you raise e to the power of both sides, and then you get that regular h minus 1 equals e to the power of sine of t over 2 plus ln of 3. So h equals, oh, it has y here. So that means you can actually just put, I don't know. Yeah, you can write, this is ln 3. You can write y equals h of t equals e to the, you're just adding 1 to both sides, e to the sine. Ah! Okay, so my stream is like really laggy, so it keeps like freezing. I have to switch between monitors, but okay. We have sine of t over 2 plus ln of, oh wow, wow. What is going on? That's horrible. Do I have to close more tabs? I already have so many tabs closed. Okay. Plus ln of 3, this is all in the exponential, plus 1 outside of it. Okay, box this answer. We're moving on again. Let's go. Alright, question 4. I think this was also on AP. Alright, so the graph of differential function, it gives you a graph of f. Okay, no prime, no whatever funny business. There is over here, though. Okay, it's shown for -6. Okay, so this is the domain. Has a horizontal tangent at x equals -2. Okay, so this is like a horizontal tangent. Okay, good to know. It is linear for 0 less than x less than 7. So this part is a line. And that's actually really good for finding a slope. So I bet we're going to have to find the slope of this line. And it's also differentiable, so it has the same slope here. I don't know if that's going to be useful. But, okay, R is the region here. It's just the region, and then it has an area of 12. So that's going to help with some integrals, obviously. So this has area of 12. Okay, so part A. The function g is defined by g of x equals the integral from 0 to x of f of t dt. So it's the area from this part from 0 to whatever x. Okay, so we want to find the value of g of -6. Okay, so first, g of -6, we can write that as the integral from 0 to -6 of f of t dt. So this is from a positive number. This is from a greater number to a negative number to a lesser number. This is so we can flip the bounds. This is equal to negative of 0 to 6 of f of t dt. This integral, and we already know that this part here, that is a curly bracket, equals 12. So that means this whole thing equals -12. So we're basically taking this area, except backwards. We're taking this area, but we're going from 0 to -6, so we have to flip the sign. Okay. So part B. I mean, it's not part B yet. It's just the second part of A, because A has 3 parts to it. G of 4. G of 4 equals the integral from 0 to 4 of f of t dt. This is actually just the area of this triangle. You can just write area of triangle. I think they'd probably take that. Equals 1/2 times the base times the height, which is 4. Okay, and the third part, g of 6 equals integral from 0 to 6 of f of t dt. Now you're just adding this part here, and this part here has an area of 1. So it doesn't really matter how you want to like express that, but one way to do it is to write it as okay. So you can express it as 0, the integral from 0 to 4 of f dt plus the integral from 4 to 6. You already know this part here. This is 4. This is 4 minus 1 equals. Let's just keep going. I'm going to try my computer screen now. 4 minus 1 equals 3. Okay, part A is done. Let's go back. Part B. For the function g, find all values in which the graph of g has a critical point. So g is this function of x. We need to have g prime of t by the fundamental theorem of calculus is the derivative of this part with respect to t is equal to f of t. I mean g prime of it's g prime of x. G prime of x is equal to f of x. Okay, and we want this to set equal to 0 to find a critical point. Okay, f of x equals 0 in this interval at x equals 4. So f of 4 equals 0, or g prime of 0, rather, equals f of 4 equals 0. Therefore, g has a critical point at x equals 4. And there are no other places where f is equal to 0. And another thing for a critical point is if it's like undefined, but it's always defined because graph is like differentiable. It's always continuous, always defined. Okay, so yeah, just have to say that you have to have this part, and you also have to say that it's equal to 0. Oh, g of 4. It's a 0. G of 4, not 0. Okay, so part C. Now this is the last part here. This we don't want to find it. We have to find 3 values again. So we now have a new function. H of x equals the integral from -6 to x of f prime of t dt. So by the fundamental theorem of calculus again, this is just the integral of f prime of t. The antiderivative is f of t. So this is just, we're basically evaluating the integral. This is f of x minus f of -6. And f of -6, it's given to be 0.5. So this is makes it really nice for us. H of 6 equals f of 6 minus 0.5. That equals, okay, f of 6, what is that? F of 6 is -1. This is -1.5. Okay, let's keep on going. H prime of 6, okay. h prime of 6 equals, this is a constant here, so h prime of x is equal to f prime of x. We can start with x here. H prime of x equals f prime of x. That's another thing. So h prime of 6 equals f prime of 6. What's f prime of 6? That's just a slope. So you probably have to write out the slope formula, which would be negative 1 minus 0 over 6 minus 4. If you're using 4, 0 as a point, this is a negative 1/2. Alright, bye, Rowan. Let's keep on going. Yeah, f prime 6 is negative 1/2. It's just the slope. Okay, so now let's go to finally, we want h double prime of 6. This equals f double prime of 6. And what you'll notice is that it's a line. It's a line. Wait. What? Oh, yeah. Okay, so it's a line. And the second derivative is concavity, and lines don't have concavity. So you can say that second derivative of linear function equals 0. Therefore, 3 lines like this means therefore. I think we're back. Okay, so the second derivative of a linear function is 0. Therefore, h double prime of 6 is also equal to 0. Okay, we're finally done. We're moving on. Let's go. We're moving on. Very, very nice. Okay, this is back to a BC only question because we have because of this thing over here. We'll get to that. But okay, so function is differentiable, whatever values of f prime. So this is f prime. For x greater than 0, the function h is defined by this thing. This is the formula for this is the arc length formula. Kind of. It's like the arc length formula, basically. So we want to find the value of h prime of pi. We don't actually have a calculator. So we're going to have to use the fundamental theorem of calculus. H prime of x is equal to, you basically just put x into the function because the derivative is the opposite of the integral. So now this is f prime of x squared. So that means h prime of pi equals square root of 1 plus the f prime of pi squared. F prime of pi, we know that to be 6. So this is 1 plus 6 squared equals the square root of 37. That's it, and that is a completely acceptable way to put an answer in for response. This is approximately 6. Okay. Part B. What information does motherfucker? Okay, so now part B. What information does integral from 0 to pi of 1 plus f prime of x squared provide about the graph of f? This is the arc length. So h of 6. H of 6 was negative 1.5. Okay. So, integral of negative, yeah, I mean, not whatever. This thing squared dx represents the arc length from basically x is less than 0, less equal to pi. So everybody, just, these words arc length is going to get you the point. I'm pretty sure that's only going to be worth 1 point. But that is a pretty free point if you recognize this. And even if you don't, it only loses you 1 point. Not a big deal. Okay, so use Euler's method. Ah, Euler's method. What is that? Starting at x equals 0. Okay, so Euler's method is basically you have a just imagine you have a slope field, and you're trying to draw a path. You go here. Okay, what's the slope? It wants you to go this way. Okay, then now it wants you to go this way. Now it wants to go that way. You're basically making discrete lines to try to sketch out a function. That's like the idea of it, and how you do it is with a table. So you have x, you have in this case f of x, and then here you have the change in f of x, and then the change in f of x is equal to f prime of x times delta x. Okay, and there's so many ways to do it with the table. Whatever really, it's really whatever. Okay, so yeah, there's a lot of ways to do the table. It's really whatever floats your boat. Okay, so we're starting at f of 0 equals 0. That is our initial condition. So we have 0 and 0. And f prime of 0, so that our step size is, okay, so delta x equals pi. So our change in f of x, the first one, is going to be delta x, which is pi times f prime of x. F prime of 0 is 5. So this is going to be plus 5 pi. This means the next value, okay, so now we're at x equals pi. 0 plus 5 pi is 5 pi. Okay, so now next, what do we have? Now we want delta x times f prime of pi. F prime of pi is 6. So we're at positive 6, so plus 6 pi. So at x equals 2 pi, 5 pi plus 6 pi is 11 pi. So this would be our approximation. F of 2 pi is approximately equal to 11 pi. Now, pi is a pretty big step size, so chances are this is pretty far off, but by Euler's method, this is what we would get. Alright, finally we have an integration by parts. They're actually just pulling this right out of their college board acorn, and just giving this to you. It has nothing to do with the entire other question. They just want to see if you can do integration by parts, and if you can, you can. If you can't, you can't. Oops. Okay. So, this is obviously a product, and t plus 5, we can take the derivative of that, but it's pretty hard to take that. Yeah, when you take the derivative of that, the function gets like a smaller degree, and that's what we want. So we want to choose a u and v. The formula for integration by parts is the integral of u dv equals uv minus the integral of v times du. This is from the this is what you get from like integrating both sides of the product rule. And then like integrating both sides, subtracting or whatever. Okay, this is the formula. There's also the DI method from black pen, red pen, where you do plus and minus. So there's a couple ways to do it. You would choose u here to be t plus 5 and v equal to cosine of t over 4. And the reason for that is because you want, once this gets like a smaller degree, you can probably integrate this. You have to be able to take the integral of this. That's the whole thing. So for the table method, this is t plus 5, and the derivative of that is just 1, which is nice. And then cosine of t over 4. The antiderivative of that, this is sine here, and then the inside, the chain is 1/4. For integration, you divide by the chain. So dividing by 1/4 is multiplying by 4. So this is 4 sine of t over 4 here. All right, we're almost. All right, so for the table method, you go across until you get to the end, and you go across like that. So integral of t plus 5. My plus looks like a t, and my t looks like a plus. T plus 5 times cosine of t over 4. Wow, I haven't gotten a freeze yet in a while. My internet's actually good. Let's go. This is equal to, you multiply across, so you can just write 4 times t plus 5 times sine of t over 4. And then minus the integral of 4 sine of t over 4. Yeah, and then this integral here. Oh. Okay, so obviously as I say that, the stream crashes, but we're back, and so we have this part here, and then this integral here. You derivative of sine, integral of sine is negative plus 16, so plus 16. No. I get like no lag, and then finally, it's like max lag. But okay. 16 times the cosine of t over 4. Now I can finally put the plus c, and there you go. You have integration by parts, probably like 3 or 4 points. All right, we're finally moving on. Last question of Calc BC. The Maclaurin series, for a function f is given by this thing, and converges to f of x for all x in the interval of convergence. Well, yeah, obviously. It can be shown that the Maclaurin series for f has a radius of convergence of 6. Okay. Okay, so it tells you that this is a radius of convergence of 6. Determine whether the Maclaurin series for f converges, and by the way, this is just Taylor series at x equals 0, centered at x equals 0. Converges or diverges at x equals 6. This is basically checking an endpoint for the ratio test. So at x equals 6, we have the series n equals 1. A series is just the sum of a bunch of terms. Okay, so we have n plus 1 over n squared times 6 to the n. And then when we plug in x, that's also 6 to the n. These are going to cancel, equals n from 1 to infinity of n plus 1 over n squared. Now, at this point, you have a couple of options. You can break this down. Now, because I don't like writing, I'm going to do it this way. I'm going to break it down into n over, I'm going to basically split up the fraction into n over n squared plus 1 over n squared. And this, I'm going to argue that this is greater than n from 1 to infinity. Okay. All right. So, to infinity. Actually, that was actually nice because I need more space anyways. This is going to be greater than the harmonic series because this is n over n squared. That's the same as 1 over n. This is positive, so each term is bigger. And if a series is greater than the harmonic series, then it's going to this thing diverges harmonic series. You can also say P series test because this is like P. This is 1. P equals 1 is not less than 1. Or sorry, it is not greater than 1. Yeah, P series. Yeah, the P series test only. The P series test converges if 1 is not greater than 1. Okay, so this is basically a direct comparison test. Also, this is a direct comparison test to the P series to the harmonic series. You can also do a limit comparison to the harmonic series, but that's more writing, and I want a mouse, so I'm not going to do that. I'm going to do the direct comparison test. Basically, the series is greater than the harmonic series. If it's greater than the divergent series, it also diverges. Basically, infinity plus anything is infinity. Okay, let's move on to B. We are almost done with the Calc BC exam. It can be shown that f of -3 equals this. What do you mean it can be shown? You're just plugging it in. But anyways, we got this, and this is actually alternating. It's alternating, which is fantastic because we don't have to do the Lagrange error. It's just an alternating series, and that is so much nicer. So, okay, this actually does not matter. We only care about the error, or the difference. So the remainder at 3 is equal to the absolute value of. It's basically how off it is, how off it is just by doing the first 3 terms, and this is less than a sub 4, less than the next term, which equals the absolute value of 4 plus 1. You're just plugging 4 into this part over here. 4 plus 1 over 4 squared times -1/2 to the 4th absolute value, so we can drop the negative, which equals 5 over 16 times 2 to the 4th is 16, so 1 over 16. And 16 times 16 is 256. So this is 5 over 256, which is less than 5 over 250 because the denominator is smaller, which equals 1 over 50. So this is smaller than this, and you're just done, basically. Yeah, you're just done here because you've shown that the remainder is less than this, which is less than this. So you basically have a chain that shows that this over here is less than this. So you can just leave it like that. All right. So we need more space, so I'm going to erase. We are almost done, I promise. And then we'll move on to AB. The other 3 problems of AB. Actually, I may or may not do those, depending on how I feel. I might just put those in a regular video. Or maybe I'll rush through them. Maybe I'll rush through them and just tell you what you're supposed to do instead of like writing it out detailed. Because the stream is getting long, and I'm not tired, but I do want to take a break. Okay. We want the general term for f prime. Okay, so f prime of x equals the integral of equals 1 to infinity. Taking the derivative of every term, this is a power rule. N plus 1, and then this n coming down here is going to cancel with an n squared. So that's going to leave us with n times x to the n minus 1. Okay, we are finally back. I think. Okay, so now we have x to the n minus 1 because of the power rule. I don't really know why I put this parentheses here. X to the n minus 1. Oh no! X to the n minus 1 over 6 to the n. Okay. Now, we want to find the radius of convergence. This is actually going to take a while because we also have to check endpoints. But It's just the ratio test. So we want to find the limit as n approaches infinity, the ratio between consecutive terms. So basically, so this is a sub n1 again is n plus 2 over n plus 1. Okay. N plus 1. That's this part, and then times x to the n plus 1, and then minus 1 again, so just x to the n. Then divided by 6 to the n plus 1. Now, dividing by is the same as multiplying by the reciprocal, so this is just n up here over n plus 1, and then times 6 to the n over x to the n minus 1. Okay, so when you're taking a limit to, this is infinity, this is just 1. This is just 1. And then these, we want this to be less than 1 for it to converge. This is going to just be x, and then this is going to be x over 6. So this equals the limit as n approaches infinity of just x over 6, which is less than 1. Okay, so now I can, there's no more n's here, so you can just take like a, now you're just left with x over 6 is less than 1, so negative 6 is less than, x is less than 6. Oh, wait, no, it's just the radius of convergence. So radius of convergence equals 6. We don't actually have to check the endpoints because we only care about the radius. Woohoo! All right, part D, last question of Calc BC. Let g of x equal this thing. Use the ratio test to determine the radius convergence. Okay, just another radius convergence, not anything absolutely insane, although this does look pretty crazy. Now we have x to the 2n. This is a completely different function. So limit as n approaches infinity. First we want, I don't know what I just drew. Can I go back? N plus 2 over n plus 1 squared. And then times x to the 2 n plus 2 because we're plugging in n plus 1 over 3 to the n plus 1. This is times, and then this is going to be interesting actually. N squared over n plus 1 times x to the 2n times 3 to the n. This absolute value is less than 1. Okay, so this squared is going to cancel out with this squared because n is going to infinity. This is going to cancel with this. And we have 1, 3. So this is n, this is also n. So we have we're basically multiplying by an extra 3 in the denominator. So you can just go to x. Okay, I think we're once again back. Very nice. I'm so fun. Okay. X squared, because we have 2 extra x's on top compared to the denominator. Okay, over 3, absolute value of this is less than 1. X squared, this is, yeah, so you can take the square root of this. Yeah, you're solving this inequality. So you can break this up into x it's always weird to solve these inequalities because you know what the answer is going to be, but like, how do you actually know for sure? Okay, let's multiply by 3 on both sides. Let's start with that. Absolute value of x squared is less than 3. Now let's take the square root on yeah, here we go. So product of absolute value of the product is equal to product of the absolute value. So you can multiply it by this. This is being multiplied here. This is less than 3. Now you can actually take the square root on both sides. You get absolute value of x is less than square root of 3. And now you can just say that the radius of convergence is equals square root of 3. Because basically x is less than square root of 3 is less than square root of 3. X is greater than square root of 3 less than square root of 3. Okay, we're done with Calc BC now. If you have any questions about my solution, you can put it in the comments. That would be after this live stream is done. Now we are going to move to AB, and if we're looking at time, we finished on time because you get 30 plus 60, and now it is 6:20. So we actually took it actually only took 80 minutes. Okay, so for Calc AB, we have 3 remaining questions. This first one here, I'm going to go a little bit quickly through this. This first one here we already did. This one here we have another particle, except you're not using any Calc BC stuff. Like I think I don't know. I don't really know why this is different. Particle moving along the x-axis. Oh, so it's like one-dimensional. So it's not, yeah, it's not parametric. It's just one-dimensional. Motion velocity is okay. So you got a velocity, and the whole idea is that the derivative of the position is the velocity. There was a time t equals tr, so basically at rest in the interval 0 less than t less than 2, where the particle is at rest, not moving. Thank you very much for the clarification. Because not everyone takes AP Physics, find t of r. Okay, and then for 0 to 2 here is the particle moving to the right or to the left. Okay, there's 2 parts here. Let's do the first part first. So part A, we want to, yeah, it's at rest when v of t equals 0. Yeah. So v of t, well, you're putting this in your calculator. This thing would go in your calculator, and then, I guess I'll find the answer. I'll do that. I'll give you an answer just to give you an answer. But yeah, so this is, you're putting this in the calculator. Natural log, where even is that button? Okay. X squared minus 4x minus 4x plus 5. And actually, it's very interesting that it gave you this because it does turn out that this expression is always positive because it's this right here, just a curiosity, t minus 2 squared plus 1. So the lowest it can be is 1. This is, yeah, it's never negative. So that's actually, so they're basically trying to make sure that no one like goes like, oh, College Board, wait a minute, it's not always existing. It is always existing. Okay, so minus 0.2t or x. Now you're going to go to second trace and intersect. Find where it equals. Oh, I chose a bad interval, but that's okay. Yeah, it looks something like this. You're going to. I did not show you that quick enough. I mean, I did not show that for enough time, but it looks like this. You're going to find that it intersects at t equals 2.883. So tr, yeah, and it tells you that there's only 1, so you can just box this up. And then if you look at the graph here, I mean, there's 2 ways to do this. You can look at the graph and say, okay, well, when t is less than this number, you can tell that the velocity is negative, so it's going to the left. Or you can say that since there's, you can say that, okay, I'm not going to write this down, but since there's only one time where it's not moving, it has to be traveling in the same direction for the other. Wait, whoa, hold on a sec. I did not do this right. I did not do this right because this time is not in the interval, so I did something wrong. Let me go back. T from 0 to 2. Wait. This is definitely not correct because it's not in the interval. But when I graphed it, it also but when I graphed it, it also um it basically it gave me that as an answer. So I think I have it put in correctly. And then when I go to trace, actually, okay, let me go back to my window. Oh, it's because of my window. It's because of my window zoom. I had the window zoom from last time, so I forgot to set it to x from 0 to 2. Now when I do it, it should just, yeah, okay. Now when I do it, it's going to draw it. Hello? What's Why is my calculator lagging? It's not even connected to the internet. That doesn't make any sense. Why is my calculator lagging? Okay, you're gonna get t equals something. I'm gonna do the other parts first. Okay, so tr equals something, and then when from t is less than 0 to t, so our particle is moving to the, oh my days. It's not oh, there it is. Now it's drawing. Okay, now it's drawing. Let's go. So we're gonna get an answer now. That makes a lot more sense. 1.426. Hopefully that's what y'all got. 6. And then it doesn't actually have units here. Okay, 1.426. Okay, and then when you look at this, when t is like less than this number, it's up. It's positive. And you can also plug in. Um, you can say that v of 1 is like something that's greater than. You can plug in v of 1, and when you plug in v of 1, you'll actually get alpha f4 of 1. You'll get a positive number. So this it's like 0.49. I don't know what's going on here. All right. I think we're back. Okay. So you get 0.49 or something, and that's greater than 0. And then since there's only one time that it's like at rest, that means moving to the right. It's moving to the right. Yeah, moving to the right because R. Okay, let's move on to B. That took way too long. Find this. No. Okay, find the acceleration. That's just v prime. V prime of 1.5. V prime. Okay, this is a number. I don't really. Actually, I can. I can. I can figure it out. I can figure it out for y'all. You just go to Math 8 and derive with respect to x. Put in y1. X equals 1.5. It's what the heck? Why is it so close to -1? Does that make sense? That's so close to -1. What? Why is it like exactly -1? Is College Board trolling? Why is it actually so close to -1? That doesn't make any sense. What? This is like a coincidence or something. And it's not even exactly one. It's like no, I swear College Board is trolling. Wait, that's funny. They're trolling. It's negative point. It's -1.000. That's so funny. That is actually so funny that it's -1.000. But okay. Um, Now it's a speed increasing or decreasing. It's basically the logic here is if you're over here, you're going if you're going this way, and the acceleration is pushing this way, you're slowing down. And if you're going this way and the acceleration is pushing this way, you're also slowing down. So if they're pointing in opposite directions, you're slowing down. And indeed, they do have. Oh, actually, v of 1.5. Just regular v of. Oh, what the heck am I doing? Just regular v of 1. What am I doing? Okay, here we go. V of 1.5 equals -0.077. So this is less than 0. This is less than 0. Same direction, so it's speeding up. Because like it's the same direction, increasing the magnitude of the velocity. Okay, part C. We're almost done, I promise. Nowhere. I don't know. I'm gonna try to go fast. Position. I'm just going to give you the answers, sort of. X of t and its position is okay. This is a star plus accumulation. We've seen this like so many times. X of 4 equals the integral from. Well, it's no, it's not the integral yet. It's x of 1 plus the integral from 1 to 4 of a v of t dt. X of 1 is equal to -3. So it's negative. Put in your calculator. Put -3 plus math 9 from 1 to not 1 to 4 of v of t. Just put y1 in dx, and then you get this -2.803. I hope this is helpful for you guys. This is the yeah. This is the setup. This is the entire setup. Part D finally. The total distance traveled. That's going to be the speed. So distance. Make sure you put the. This is actually where a lot of people tend to go wrong, but it's the absolute value of the velocity, and the reason for that is it changes direction. So it goes over here, and it changes direction. If you just do the velocity, you're going to find the displacement. So this part minus this part, and you're basically going to forget about this thing over here because you're only taking the end point minus the initial point. You need to take the absolute value of it to take, because this is the speed. You're integrating the speed over the distance, and the speed doesn't care about the direction. So the total distance is different from displacement because displacement is only final position minus initial. But the distance is, and also displacement is a vector. Distance is a scalar. Distance is like one of the only scalars that are actually existing in real life, other than like charge or mass or whatever. You have to do the absolute value of the velocity, or you can split it up into two. But ultimately, you're doing the absolute value of the velocity, and you can do it different ways. But this is the correct answer. You need to take the absolute value of the velocity to get the speed, and in your calculator, that actually works pretty nicely. You can just put the absolute value. Um, Okay, that's the end of my absolute value yapping. But um, where even is the absolute value function? Is it in math? Oh, okay. So you have to go to math, go over to num, absolute value, and then you put in y1 dx, and you get it's going to be a positive number also. The distance is traveled is a positive number. It takes a while on my calculator, but I got 0.958. I'm pretty sure it's the correct answer. If you got anything different, put it in the comments and tell me how you got it. But I'm pretty sure this is the correct answer because it's the I am sure this is the correct answer because it's the absolute value of the velocity. And just for demonstration, if you don't put the absolute value here, you're gonna get an answer from your calculator, but it's gonna be different. And I'm gonna bet that this is actually going to be a lot less than this because you're not accounting for changing direction. Math 9 from 1 to 4 of y1, just regular y1 dx. And indeed, yeah. See, it's like 1/5 of the distance, so that would be wrong. And you'd have no way to tell that it's wrong because like it's not a negative number or anything. So this is probably one of the trickiest questions. You have to make sure you do the absolute value. Let's move on. Let's move on. We've done that one. We've done this one. It's just these ones here. Okay, this one's hopefully we'll go pretty quickly. We get implicit differentiation. The curve defined by this. This is actually a conic section. I think this is an ellipse. It's an ellipse. And how do I know it's an ellipse? It's because it's x squared and then y squared, and then you have like a scalar here. They don't have the same leading term. Okay, so it can be shown. Very, very nice. They don't actually make you do the implicit differentiation. They do it for you. Very cool. There is a point on the curve near 2, 4 with x coordinate 3. Use the line tangent. Okay, so the line tangent, you need a point and you need a slope. That is what you need. You need a point and you need a slope. Okay. What's going on? I was writing to my friend. Okay. In the chat. There is a point with okay, so we want the tangent line. We already have the point. We need the slope. Dy over dx at the point. This line just means at the point 2, 4. You're plugging in. This is going to be negative 2 times 2 over 3 plus 4 times 4. Okay, this is negative 4 over 19. And you actually don't get a calculator for this, which is kind of unfortunate. But yeah, okay, now point slope form, y minus 4 equals the slope m times x minus x1, which is 2. Y of 3 is approximately equal to, yeah, you can move this over here, negative 4 over 19 times 3 minus 2 plus 4. And since it's free response, you can actually just box this up. No need to simplify it. It would be 72 over 19. Yeah, I just did that in my head. So okay, so now part. Okay, now part B. Is the horizontal line y equals 1 tangent to the curve? Give a reason for your answer. Okay, so what does it have to? What does? Okay, so for something to be tangent, it has to intersect it, and it also has to have the same slope. So, wait. Yeah, okay, okay. So we have to solve for okay, does the line intersect it? Does it intersect this curve? Let's just plug in y equals 1 and see what happens. X squared plus 3 times 1 plus 2 1 squared equals 48. Okay, this is 3 plus okay, so x squared equals 43, so x equals plus or minus square root of 43. Okay, what can we do with this? Um, well, basically, yeah. So if what's the slope of y equals 1? Well, it's 0. So dy over dx at plus or minus root 43. I don't know if this is good conventions or not. You can probably just choose one of these points. All you have to show really is that the derivative doesn't match up. If the derivative doesn't match up, then it's not tangent. This equals like, okay, this is gonna be plus or minus 2 root 43 over 3 plus 4 times 1. This is not equal to 0. Okay, not equal to 0, not tangent. Derivative doesn't equal 0, not tangent. Okay, let's keep on going. Curve intersects the positive x-axis at this point. Is the line tangent to this point vertical? Okay, well, is the derivative like undefined? Can we have a 0 here? Dy over dx at this feels really simple, but I think it's just testing if you can plug it into a differential equation. This is not like it's not undefined. It's not undefined, so it's not vertical. Not undefined, not vertical. That's all you have to do. Okay, now we actually have a question. This is actually related rates, which is absolutely wild to put on top of all of this. I think, and because this is related rates, I think that it is just as simple as this. Okay, so it's moving on another curve defined by this. At the instant the particle, now we have t. Now we have t's involved. So basically, we're going to take the derivative implicitly of both sides with respect to t. So now instead of like y prime, we have dy over dt because y and x are changing with respect as time changes. At the instant the particle is at the point 4, 2, the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. Okay, so we have an initial condition, nice. We also have the dy over dt. So let's just write out all the information we have. Y equals 2, dy over dt equals negative 2, and x equals 4, and we want to find dx over dt. So it asks us what's the right change of the x-coordinate position with respect to time. So that's the dt part. All right, so take the derivative with up both sides. So 3y squared times the chain rule. So y depends on t. So this is multiplied by dy over dt. This is related rates. Plus, now we have a product rule. So 2x times the derivative of this part, dy over dt, plus 2 times the derivative, 2y times the derivative of x with respect to time equals, okay, this 24 is a constant, that's 0. All right, so now plug in the values here. 3 times 4 squared, 3 times 2 squared dy over dt plus 2 times 4. I'm hungry, I want to eat. I'm going to rush through the next one. We're so close, we're almost done. 2 times 2 dx over dt. I'm going to do the rest of my head. Dy over dt equals negative 2. Move this over here. That's 2 times 20, which is 40. 40 divided by 4 is 10. Dx over dt equals positive 10 units per second. That may or may not be correct. I think it is though. I think it is correct because this is 12, right? This is 12 plus 8. Move that over here. That's negative 20. And then dy over dt negative 2, so that's positive 40. Positive 40 divided by 4 is 10. Let's move on. This is cringe. This is really, really cringe. Okay. A is the region bound by the graphs of f and g. R from here to here. So we just have two quadratics, basically. Right, but do not evaluate. This is very, very nice. We don't have to evaluate it. Because I want to be done. And ignore reference that gives the area. This is just top minus bottom. Very, very nice. A equals the integral from 0 to of the top function. I don't know if you can write f of x or g of x, but just, yeah. F of x is the top function, x squared plus 2 minus parentheses, make sure you got the parentheses, minus 2x dx. And they could totally ask you to evaluate this. I mean, if they told you to evaluate this, then the answer you would get would be 8. Yeah, you would get 8, but they don't ask you to evaluate it, which is kind of nice. Um, B. Let S be the region of the solid. Yeah, x equals 2 to x equals 5 is the base of a solid. For the solid x, the cross section perpendicular to the x-axis is a rectangle with the height equal to half its base in region S. Okay, so um, it's always going to be x. It's always going to be f of x squared, and there's going to be some sort of scale factor because it's 1/2 base times height. I mean, no. A rectangle, uh, a equals base times height, and the height is 1/2 its base, so it equals 1/2 b squared, and b is f of x. Okay, so the volume equals to integral from 2 to 5. Oh, what the heck? This is a gnarly integral. Okay, g of x, it's just 0, but luckily it's just bounded by g of x and 0. So the base, the perpendicular, whatever, it's just g of x. So it's 1/2 times g of x squared dx. That is not very nice to evaluate at all. In fact, it's so bad that I don't even want to do it, but I am going to anyways. Okay, so we got to expand it out. X to the 4th minus 4x cubed plus 4x squared dx. This is an absolute abomination. But okay, but to be fair, this is the only thing that you're evaluating in this entire problem. So sure. But whatever. This is still I don't like seeing this at all. Okay, there's no way I'm simplifying the final answer though. So let's just take the antiderivative. This equals this, it equals this. I'm gonna get rid of this. Nothing that's not. Oh, if you like cross it out, it erases for you. That's nice. Okay, antiderivative time. 1/5 x to the 5th. I'm gonna check my chat quickly. Oh, you didn't get an answer. Uh-oh. For the last one? For 10? Oh, I could be completely wrong here. It's possible that I'm just completely wrong. It's possible for this one. I could be wrong here. I don't I think it's plus 10. Um I don't know. I think it's right. Maybe it's not though. I'm not totally certain, but I'm pretty sure. Minus okay, x fourth plus 4/3. By the way, thank you, Daniel, for watching this entire stream. Like that's like insane. Like I appreciate it so much. Okay, and at this point, actually, it's not so bad because on an AP exam, you can just write 1/2, big bracket, 1/5, 5 to the 5th, minus 5 to the 4th, plus 4/3, 5 cubed, and then minus, keep it in the big bracket, parentheses. You can have parentheses about this too. 1/5, 2 to the 5th, minus 2 to the 4th. Make sure you plug all these in correctly. That's all you have to do. You don't have to evaluate this. That would be an absolute nightmare. Box this up and you're done. This is what you're looking for. Do you want me to evaluate this? Should I evaluate this into like a fraction? Should I do it? I don't know. I'm gonna do C first, and then I'll see if I feel like it. Okay, part C. Write but do not evaluate an integral expression that gives the volume of the solid generated one region S is rotated about the horizontal line y equals 20. So y equals 20 is all the way up here. Okay, so this is the washer method. This is the Uh, okay, so the horizontal line, this line here is what we're revolving around. This is the washer method. This is going to be the outer minus inner. So what's farther from this line here? Is it this curve or is it this curve? It's this curve. So this is actually 0. Um, so the volume equals, and don't forget pi. Do not forget pi. Pi is like pi, so you have to have pi. And then for the the s is bounded from 2 to 5, so that's 2 to 5. And then you have outer radius minus inner radius. What is the outer radius squared? That's just 20. 20 minus 0 is 20. So you can write 20 minus 0 or just 20. 20 minus 0 squared. And then minus the inner radius. What is the inner radius? So the inner radius is the distance from this line to the function. That's binding it. That's binding it. Bounding. So that is g of x, but it's not just g of x, it's 20 minus g of x. That's the distance from the rotating axis to the curve. So that's the inner radius. So this is 20 minus g of x. Learning this for the first time, it's really confusing. Like, is it g of x? Is it 20 minus? But the radii are with respect to the axis of rotation because that's where you're rotating it. So the outer radius is 20 minus the outer portion here, and that's 0 minus the inner portion here, which is g of x. So 20 minus g of x all squared. And make sure you square the radius is like this. This is basically big R. This is little r. dx. Box it up, and we're done. We're done. Let's go. Oh, wait. I'm going to evaluate this. Okay, I'll do it. All right, so I'll do it in my head. 1/5. Okay, this is 625. Oh, 625 minus 625. This is 0. That's nice. Okay, 5 cubed is 125 times 4, 500 over 3. 500 over 3 minus, okay, 2 cubed is 8. 32 over 3. 500 minus 32 is 468. 468 over 3 is actually a integer, and that integer is equal to 156. So 156, and then we have this part here, 32 over 5, and then this is negative, negative, this is positive. 16 minus 32 over 5 is 80 minus 32 all over 5. That's 48 over 5. That is a positive number. 42 over 5 plus 156 is 156 times 5. That's half of it times 10. 780 over 5 plus 48. 780. 828 over 5. Oh, there's also a 1/2. There's also a 1/2. So just take half of this. 414 over 5. And I'll put it in my calculator now. You don't get a calculator. You do not get a calculator on this portion, but just to check the integral, I'm going to put it in my calculator. If this is correct, I'm ending stream immediately, and I'll be very, very happy. Okay, so 1/2 times the quantity x squared minus 2x all squared dx. And the calculator is going to be decimal form, 82.8. Oh, let's go, 82.8. We are so crap. Oh, my mom is in the chat. When will I have dinner? I will have dinner right now, Mom. All right. That is the end of this. That's the end of the stream. Thank you so much to everyone who stopped by, and if you're watching this after the stream has ended, thank you so much for watching this video. Hope you learned something from this, and I hope you enjoyed figuring out what you got right and what you got wrong. And I will see you in the next video. Yeah, so thank you so much for watching. And this is my first live stream. It went pretty well.